Hi again. Do you take your coffee with milk? Come, I'll make you one. Okay, remember, we need the milk because it's consumed in the coffee making process. That will be enough. We're going to use the milk to make the latte. Put it back in the machine, and we're ready to go. Just press the button. Meanwhile, let's continue modeling our coffee making system. After we've learned about... Okay, I think that will be enough. After we've learned about two types of transformation, consumption and creation, we learn about the remaining third type, change or state transition. The milk was still cold. Before pouring it to the coffee, we want it to change from cold to hot. To model this, we introduce the concept of state. A state is a situation or position the object is at some point in time. Our milk is currently at state cold. We wish to change the state from cold to hot. To model this, we are now adding to milk these two states. The heating process, which we are adding now to our model, will change the milk object from its input state, cold, to the output state, hot. To model this, we drag an imaginary line from the input state, cold, to the transforming process, heating. In the table that just popped up in OpCloud, we select the option in which the sentence will be heating changes milk from cold to hot. Exactly what we want to model. Indeed, this sentence is what we get now in our OPL window. Heating changes milk from cold to hot. The milk object is connected to the heating process with an input-output link pair. A pair of links comprised of an input link from the input state cold to the heating process and an output link from this process to the output state hot of milk. Now we can add the hot milk into your coffee. The little milk we have left will go to Hopcat, our little smart cat. The capsule here also underwent state change from new to punctured. This was done by the puncturing process inside the machine. Looking back at our flight journey system, we see state transitions there too. Let's follow your journey through the airport. Before flight ticket purchasing ends, passenger U is in a state of being pre-ticketed. Once this process ends, the passenger state changes to ticketed. Following boarding, passenger state changes from ticketed to having a boarding card. Actually going on the airplane, which is also called boarding, is physical, as it changes the state of passenger to boarded. Landing changes the passenger state from airborne to landed. At this time, you thought you would have your suitcase in the carousel, so the suitcase would be at state found. Not retrieving it means losing it, changing its states from found to lost. Finding does the inverse, and it changes the state of suitcase from lost back to found. Back to your coffee, it is now ready. Not less importantly, you now have the initial tools required to conceptually model any system. With this knowledge, you already know how to create an initial model of an electric car and how to present this model to the company you're interviewing for, StoreDot. The company develops ultra-fast charging batteries. While driving, the electric car consumes electricity. Here is an OPM model of this. Following charging, each cell inside the car's battery changes from depleted to charged. This means that the charging process changes the state of the cell from depleted to charged. More critically, your application process to StoreDot changes your state from candidate to employee. The learning process you have gone through so far is changing the state of your knowledge, and through the learning process you are gradually becoming an OPM expert. You can use this knowledge in every company, product, or system you are involved with.
Input-output link pair is a pair of links from an input state to a process, and from that process to the output state.